Example 6, find the integral of tangent to the fifth power theta and secant to the seventh power theta d theta. Solution: if we separate a secant squared theta factor, as in the preceding example, we are left with a secant to the fifth power theta factor, which isn't easily converted to tangent. However, if we separate a secant theta tangent theta factor, we can convert the remaining power of tangent to an expression involving only secant using the identity tangent squared theta equals secant squared theta minus 1. We can then evaluate the integral by substituting u equals secant theta, so du equals secant theta tangent theta d theta. The integral of tangent to the fifth power theta secant to the seventh power theta d theta equals the integral of tangent to the fourth power theta secant to the sixth power theta secant theta tangent theta d theta equals the integral of open secant squared theta minus 1 close squared and secant to the sixth power theta secant theta tangent theta d theta equals the integral open u squared minus 1 close to the power 2 u to the power 6 du equals the integral of open u to the power 10 minus 2u to the power 8 plus u to the power 6 close du equals u to the power 11 over 11 minus 2 u to the power 9 over 9 plus u to the power 7 over 7 plus big C equals 1 over 11 secant to the 11th power theta minus 2 over 9 secant to the 9th power to the power 9 theta plus 1 over 7 secant to the power 7 theta plus big C. The preceding examples demonstrate strategies for evaluating integrals of the form the integral of tangent to the power m x secant to the power n x dx for two cases, which we summarize here. Strategy for evaluating the integral of tangent to the power m x secant to the power n x dx. Part A, if the power of secant is even, open n minus 2k and k greater than or equal to 2, close, save a factor of secant squared x and use secant squared x equals 1 plus tangent squared x to express the remaining factors in terms of tangent x. The integral of tangent to the power m x secant to the power 2k x dx equals the integral of tangent to the power m x open secant squared x close to the power k minus 1 secant squared x dx equals the integral of tangent to the power m x open 1 plus tangent squared x close to the power k minus 1 secant squared x dx. Then substitute u equals tangent x. Part B. If the power of tangent is odd, open m equals 2k plus 1, close, save a factor of secant x tangent x and use tangent squared x equals secant squared x minus 1 to express the remaining factors in terms of secant x. The integral of tangent to the power 2k plus 1 x secant to the power n x dx equals the integral open tangent squared x closed to the power k secant to the power n minus 1 x secant x tangent x dx equals the integral open secant squared x minus 1 closed to the power k and secant to the power n minus 1 x secant x tangent x dx. Then substitute u equals secant x. For other cases, the guidelines are not as clear cut. We may need to use identities, integration by parts, and occasionally a little ingenuity. We will sometimes need to be able to integrate tangent x by using the formula established in chapter 5.5.5, which is the integral of tangent x dx equals the natural log of the absolute value of secant x plus big C. We'll also need the indefinite integral of secant. Sidebar: Formula 1 was discovered by James Gregory in 1668. His biography on page 198. Gregory used this formula to solve a problem in constructing nautical tables. Back to the text. Equation 1. The integral of secant x dx equals the natural log of the absolute value of secant x plus tangent x plus big C. We could verify Formula 1 by differentiating the right side, or as follows. First, we multiply numerator and denominator by secant x plus tangent x. The integral of secant x dx equals the integral of secant x times secant x plus tangent x over secant x plus tangent x dx equals the integral of secant squared x plus secant x tangent x over secant x plus tangent x dx. If we substitute u equals secant x plus tangent x, then du equals open secant x tangent x plus secant squared x close dx. So the integral becomes the integral open 1 over u close du equals the natural log of the absolute value of u plus big C. Thus we have the integral of secant x dx equals the natural log of the absolute value of secant x plus tangent x plus big C.